Is in this chapter, in this lecture, we will be briefly reviewing the concepts of your fourth and fifth semester, right? So I will go very quickly on the equation that you have already done in your fourth semester regarding stresses in soils. Stresses from elastic theory. So we use elastic theory to find stresses in the soil. So when you use elastic theory, it means principle of superposition works. The stresses from one point load can be added to stresses with the stresses from another point load. The point load, right? And there's distribution of stresses in the horizontal and vertical direction. This is a stress is due to a line load, and these are the corresponding equations. Strip area carrying a uniform pressure. These are equations, right? Due to stress is due to a strip area, like from a strip foundation or from a wall of from the footing of a retaining wall. All the three stresses in the vertical direction sigma z, stresses in the x direction sigma x, and tau xy are given. This is a pressure bulk due to strip loading. You are aware of the concept of a pressure bulk. You have studied in the fourth semester. You see, this is in Q intensity is a strip footing, and as you go down, the stress is due to load decreases. Till that, the 20% of the applied pressure comes down to the depth of equal to 3 times width of the foundation. You see, so on the entire pressure bulk, the intensity of the pressure due to Q is reduced to 20%. This is an example, and it is solved here. You can have a look at it, and you can use the corresponding equation to find these stresses. Do try this problem at your home so that the concept you have studied in fourth semester are reviewed. You memorize all these equations. Circular area, uniform pressure. You have a circular area like circular of radius r, and there's a pressure. It's a circular foundation, right? The pressure is Q, and you want to find stresses under the center of footing, right? Under the center of footing, stress, for example, delta sigma z. So the equation for this is this one. This is radius r, and this is depth z at which you want to find stress, right? This whole factor in parentheses is called IC, right? Is represented by C, and Q comes like this, QIC. For IC you can use this graph. For IC you can use this graph, or you can use this equation. D by Z is the diameter of the footing, and Z is the depth. So you find D by Z and you find IC from the graph, put it here. Remember that this equation gives you stresses under the center of footing. The last one is the Bosniak equation, which gives you stresses under a rectangular footing. So you have a rectangular footing, this is L and this is D, right? The Bosniak equation again gives you stresses under the corner of footing. If you want to find stress under the corner of footing, you need to use Bosniak equation, which is delta sigma Z is equal to Q, which is the applied pressure, M I sigma. I sigma you can use a graph. You can use a table for, graph for this. Graph. What is M? Can anybody tell me? Can anybody tell me what is M?
Sir, M is equal to 1.
M is the number of corners contributing to the stress, right? If you want to find a stress under the center of footing, so this equation is not directly applicable. For this to be applicable, you need to divide the rectangle into 4 sub-rectangles and find the stress for this rectangle. Here, now B would be equal to B prime by 2, and L would be equal to, L would be something wrong, okay. B is equal to, B prime is equal to B by 2, and L prime is equal to L by 2, right? But there are 4 rectangles, 1, 2, 3, 4, so M would be equal to 4. But if you are going to find under the corner of footing, that is M is equal to 1. But if you want to find here in the edge, the rectangles are 2 now, 1 and 2. So here M would be equal to 2, right? So now, how to read I sigma from the graph? That's the question. You have done this in your 5th semester, in your 4th semester. You remember this graph? Here is this graph. On the x-axis, you have M, which is equal to B prime by Z. And on the y-axis, you have N, which is equal to L prime by Z. So for example, your m prime is, for example, equal to 2, and what your n is equal to, for example, 0.45. So how to read this? M is equal to 2 is here. This is m is equal to 2. You see this line is for m is equal to 2. And now n is 0.45. You see this is zero point 0.1, this is 0.2, this is 0.3, this is zero point 0.4, this is 0.45. So you have to come to the middle of these two, 0.45. A line like this, you see here. So it is approximately 0.12. You see I sigma is 0.12. You got the idea? Do you have any question?
Yes.
जी बताएं. Okay. If you don't have any question, let's move on to next to solve a problem with this. An example, right? Let's use an example to solve this. अच्छा जी. This is a problem that you would solve it yourself. The question is, I just place it here for you. The question is to find stress under point A. This is a top view, this is a plan view, right? It is a plan view, but at a depth of 3 meter below point A. Below point, that is the question. What do you say? Point A is not at the corner. It is outside the corner, right? But the equation that I told you, delta sigma z q sigma and m is applicable to the corners, right? So what we would do, we would we would find the stress for this area. You see, you find the stress due to this rectangle and use m is equal to 2. But there is a problem. The problem is this: in this stress that you find here, this area is additional, has additionally come. This area has additionally contributed to the stresses. So do you have any idea how to remove the effect of this zone from delta sigma?
सर इसके लिए
जी.
अलग फाइंड करेंगे, ये टोटल से सब्ट्रैक्ट करेंगे सर.
Yes, इसको अलग सब करेंगे, and this is that portion. And the negative sign shows that you have to subtract. ठीक है ना? Again you find stress at this point m A or m equal to 2. Okay, that is a revision of your fourth semester. Now let's apply the stress calculation to a real foundation problem, right? this is a real problem, right? मुझे एक 2 मिनट दे, मैं पानी पीता हूँ. अच्छा जी. अच्छा जी. I hope you all hear me and you are with me now to solve this problem. Uh, this is our foundation at 10 feet depth and 8 by 8 feet size and 375 kip load is applied. Remember this, that this footing is at 10 feet depth from the ground surface. So first you have a silty sand, you say silty sand, and this is 16 feet deep, and then you have a soft clay which is 10 feet. So what we are going to do, we would find stresses in the soft clay. In the soft clay, you see this is a soft clay under the center of footing. The question is to find stresses under the center of footing at different points. So we would divide the clay layer into 5 equal parts. Okay, 4 equal parts. To each 2.5 feet and into 4 is equal to 10 feet, right? So 1, 2, 3, 4. Each sublayer is equal to 2.5 feet. So at the rate of 2.5 feet into 4 is equal to 10. So what we are going to do, we would find the stresses at this point, okay, at this point, and at 5 points, right? So this is point 1, this is point 2, this is point 3, this is point 4, and this is point 5. The value of Z depth from the foundation, from the foundation base, that is Z. For point 1, Z is equal to how much? Can anybody say for point 1? How much is the Z value?
6.
Good. It is 6 feet. 6, beta 6. 6 feet. 16 minus 10 is 6. This is 6. For point number 2, Z is equal to how much?
8.5.
8.5.
8.5. For 3, add 2.5, it is 11 feet. At point 4, it is 13.5 feet. And at the end, Z is equal to, for point 5, this is 16 feet. So we have the Z values 6 feet, 8.5, 11, 13, and 16. Who would find stress for every depth? Right? For every depth. So let's do this. Let's make a table. Table is serial number here, value of Z here, value of M here, value of N here. Okay, let's be a bit broad. Okay. This is serial number. This is depth Z. This is the value of M, which is equal to B prime over Z. This is N is equal to N prime over Z. This is the value of I sigma. And this is the stress equation, right? This one is delta sigma Z, which is equal to, very difficult to write. Just a minute. Let me write it for you. In any case, M I Q M R Q M Q into M into R, and that is equal to delta sigma. Delta sigma. Here you. Okay. So this is 0.1, 0.1, 2, 3, 4. We had 5 points and we have different depths. Depths were 6 feet, right? 8.5 feet, here 13 feet, here no, कुछ गलत हो गया है 6, 8.5, 11 feet, here 13.5 feet, right? And at the end you had ये क्या हो गया? What has happened? At the end you had 16 feet, right? Now you have M by Z. For this one case, I would do M is equal to B prime with us is 4 and depth is 6, so it is 0.67. Also, it is same because it's a square footing, 4 by 6, 0.67. So what is the value of I here? That we need to investigate. For m is equal to 0.67, n is equal to 0.67. What is the value of I? Let's see from the graph. 0.67. So this is you see this is 0.2, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.6, and somewhere here is 0.67. This is a line 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6. Okay. Somewhere here is 0.67. That is a line of m is equal to 0.67. Now n. These are different values of n. You see, these are different values of n. N with you is 0.67. So see, this is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, and this is 0.7. So just below 0.7 is 0.67. So if you come down like this, somewhere here, you see, this is 0.121. I is 0.121. Here, I is 0.121. Right? Now, I sigma would be equal to Q. What is the value of Q? What is the value of Q? G. Can anybody say?
375 into
375. G.
Divided by 64.
Will divide by 8 into 8. This is the value of Q. And this is equal to what? कोई बता सकता है? जी करें मतलब
5.85.
5.85. यूनिट भी बताएं. यूनिट भी बताएं.
Kip per feet square.
ASF. ठीक है ना? So 5.85. 5.85. So come here. Five is equal to 5.85 into 4. M is 4 because under the center of footing, into I is 0.121. So you calculate the value of delta sigma. Same goes here. Same is for this, for this, for this, and for this. And at the end, you will get some stress values here. Let's write all of them. These stress values are here. You see, I found the stresses from the table and put it here. Oops. This is for 2.84 for 6 feet, 1.81, 1.21. And you see, I plotted them. This is the stress axis, and this is the depth axis Z. Right? Here, rather Z starts from here, right? So Z is 6 feet, you have this stress. You see the stress distribution decreases. As you go down, the stresses decreases. These are stresses due to load. Rather change in stresses in the soil due to foundation load. Remember this, because the stresses due to self-weight of soil would increase with depth. It would be like this. The stress is due to, that is due to soil weight, soil self-weight. It increases with depth, but due to load, it decreases with depth, right? Any question up to this point? Do you have any question up to this point? Abid Ali? Mr. Abid Ali?
Yes, sir. Yes, sir.
Are you okay with it? Any question?
No, sir.
Okay. So let's move on.
Okay, sir.
Okay. So now the next step is to find. The next step is to find. I don't know. That's simple. Archer. The next step is to find delta sigma average. Average stress increase in clay layer. In this layer, which is clay layer, because you see the stress is decreasing with depth, now it asks what is the average stress? What is the average stress increase? Delta sigma. Average. What is the average stress increase? So to find average stress increase, you need this to find first this area under the curve, shaded area. Right? Make it shaded. This area. First you find this area, right? And then delta sigma average would be equal to area divided by thickness, this thickness h. Which is equal to, in this case, equal to 10 feet. So how to find the area, rather the shaded area? First, now let's find the shaded area, right? The shaded area can be found from using Simpson's rule. Using Simpson's rule, you know. It is a numerical integration method, Simpson's rule. What does it say? It says that area would be equal to, at the first and last ordinate, which is 2.84 plus 0.63. divided by 2 and add rest of the ordinates which are 1.81 plus 1.21 plus 0.8686, and then it says that you multiply this with the increment of each is 2.5 feet. Fine. That would give you the area. So area is I think this
14.
area is 14.04. 14.04. Now delta sigma average would be equal to area over depth h. So that is 1.404 KSF. So this is the problem. Any question? Do you have any question?
No, sir.
Okay, let's move on to another method of stress calculation, which is a new for you, but it's the easiest method. That is called slope to one method. It is called slope to one method. Slope to one method of stress calculation. In this method, what we do, this is a foundation and applied load is Q is the applied load, and you want to find stress at any depth Z, delta sigma Z. You want to find delta sigma Z at this depth, right? So what we assume in this method that the stress distribution is like this, with a slope of 2, 1, the slope of 2, 1, right? So if you want to find delta sigma Z at depth Z, that should be equal to Q divided by this area, and that area is B of this area at depth Z into L of this area at depth Z. So what is BZ? Can anybody tell me? BZ actually is this distance. This distance is BZ. So what is this equal to? Definitely this is the B, right? So this B is bigger. How much is this B? You see, this is B. This distance is B, and this distance is, if this is 2 slope 2, 1 method, it means if it goes vertically by a distance Z, it will go laterally horizontally by a distance Z by 2. So that distance is z by 2. And this distance is also z by 2. So that this is b plus z. And Lz would be equal to L is perpendicular to the screen, so L plus Z. So if you put this value here, you would have an equation like B plus Z if you have a sphere footing in which B is equal to L, your equation reduces to do you have any question on this? Ashfaq Ahmad, Farah, do you have any question?
No, sir.
Afaq Ahmad Faraj. You don't have any question. Okay,
No.
let's move on. Let's move on. Now you are asked to find delta sigma average using slope to 1 method. Using slope to 1 method. So let's do it. This is the stress distribution you found out using slope to 1 method at different depths. Right? Again, to find delta sigma average, you would find area and divided by h, or sorry, or h here, because h. You want to find average stress increase in this layer. Average stress increase. So area. Now let's find the area, right? So in Bosniak equation, you use Simpson's rule. That is a numerical integration method. But here the equation is very simple, so you would use actual integration. Actual integration. Let's use actual integration method and solve it. ठीक है ना? Okay. So you would take a strip, a small strip. You see this strip. The thickness of this strip is dz, and it is located at a depth of z. This ordinate is delta sigma z. delta sigma z. Okay. So the area of this small strip DA is equal to what? Can anybody tell me what is the area of this small strip? Faryal Keramat, can you tell me what is the area of this small strip?
Yes, ma'am.
Faryal Keramat. Faryal, where are you, boy? Bashir Ahmad. Bashir.
So dz into delta sigma z.
Good, good. Delta sigma z into dz. Right? Now we will integrate this from 0 to a, and here from z1 to z2. From 0 to a and from z1 to z2. What is z1 and z2? This is the from foundation base to the top of the layer is z1, and from foundation base to the bottom of the layer is z2. So h is equal to z2 minus z1, right? So these are the limits. If you integrate this, that would become area, and you put the value of delta sigma z here. What is the value of delta sigma z here for square footing? Q divided by b plus z square, the one that you just derived. The one you just derived. And you integrate it and divide the area by height h. You have delta sigma average. These are the this is the integration done for you. This is the integration already done for you. You look at it, this. And the last equation that you get for sigma delta sigma average is delta sigma average is equal to Q divided by B plus Z1 and into B into B plus Z2. This is the equation, you see. This is for average. But what this is, what is the difference between these two? Can anybody tell me? What is the difference between these two equations? जी क्या बताया आपने, प्लीज बोलो. पॉइंट क्या मतलब है, पॉइंट किस पॉइंट पे, किस पॉइंट के लिए? कौन सा डर, क्या नाम? ठीक बताया आपने, मगर जरा टू बी मोर स्पेसिफिक. Anybody else? Anybody else? यार दोनों इक्वेशन में क्या फर्क है अभी मैंने डिराइव किया आपके लिए जी
So जी ये फर्स्ट इक्वेशन हमें डेप्थ z पर जो है ना एक पॉइंट पर स्ट्रेसेस हमें देते हैं वो जो z डेल्टा सिग्मा f
देखें
वो
गुड 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 this gives us stress at point depth z from the foundation base at depth z from the foundation base and this give us average stresses in the layer average stresses in the layer right okay good now let's solve a problem let's solve a problem ये क्या ये you use that equation you use this equation ये इसको जरा अच्छा you find the stress every stress in this 10 feet clay layer using slope to 1 method using Bosniak equation you found it was 1.41 ksf but now use slope to 1 method to find every stress increase in soft to very soft clay layer आप करें जी जी स्टार्ट करें एक 5 मिनट में आपको देता हूं यू सॉल्व द प्रॉब्लम
Yes.
remember this equation is only applicable to square footing right so you put this equation what is the value of z1 what is the value of z1
6.
g
6
this is z1 equal to 6 foot what is the value of z2 this is from here to the bottom
15.
how much is तो क्या आता है इससे
16.
इससे क्या आता है डेल्टा सिग्मा एवरेज दैट इज पी और क्यू एक चीज है ठीक है ना दैट इज लोड ऑन द फाउंडेशन क्या आंसर आता है जी क्या आंसर आता है व्हाट इज द आंसर I wonder if you can hear me. Can you hear me? Hello?
Yes, ma'am.
तो आप बताएं ना क्या आंसर आ रहा है तो बताओ ना बेटा 1.11 KSF बताएं यूनिट जरूर बताएं KSF ठीक है ना now that is the average stress increase in the layer this is the average stress increase in the layer now if I ask you to find stress at the mid of the clay layer, somewhere in the middle of the clay layer, here, what would be delta sigma z? Here, वो find करें. At the middle of the clay layer, उसकी क्या value आती है? Q ठीक है ना हिलाल शेर अच्छा मिस इकरा आप बताएं व्हाट इज द वैल्यू ऑफ z मिस इकरा okay she says Miss Ikra says it is 7.5 feet. No, it is not 7.5 feet.
11.
That is wrong. जी बताएं. Yes, Mansoor is okay. Mansoor says it is 11 feet. Mr. अच्छा वो तो बात की बात है मैं z की बात कर रहा हूँ z is from here to here this is 6 feet and this is 5 feet that is 11 feet right तो 11 feet पे क्या आ रहा है आपसे 1.04 KSF and you see this is very close to the average stress you found from slope 2-1 method. ठीक है ना? Another thing that I want to ask you is at mid depth where z is equal to 11 feet, right? From slope 2-1 method and from Bosniak, you can compare those. From slope 2-1 method, it was 1.04 delta sigma. You just found it, yes. And from Bosniak equation, what is the value? You just found it, right? Let's go and see. अच्छा. Now, हामिदुल्ला, मिस्टर हामिदुल्ला, आप बताएं. Okay, okay. Mr. Hamidullah, tell me from Bosinic equation, what is the stress at mid depth? Hamidullah. जी हामिदुल्ला, आप बताएं. It is, you see, 1. बस छोड़े हामिदुल्ला, आपने बहुत देर कर ली. It is 1.21.
Sir,
1
sir,
point.
my problem.
Okay, no problem. 1.21 JSL. So Bosinic, Bosinic equation is more accurate, right? Than the slope to 1 method. But slope to 1 method is easy to apply than Bosinic equation. Okay, that's the end of this lecture. I hope you understood. Now, all of you should leave except those who have